out of an image. Okay. And the way you want this is by making an image where you decide that above this threshold, I'm considering signal, and below this threshold, I'm considering it not signal. So you're making an image binary by making it yes and no, 0 or 255 in an 8-bit image, right? So computers work in a binary code, right? 0 and 1. In our case, it's going to be 0, 255. Sometimes I will say 0 and 1 because the idea is the same, right? You want to make sure that that you have signal and no signal. And you want to threshold your image in a way that you can really nicely separate out what's signal and what's not signal. The reason why you want to do that, because then afterwards you want to generate your structures that are the ones that you are analyzing, okay? And this is a whole submenu. It's the binary submenu. And what did I write here? They assume that the objects are black and the background is white. So make sure that in when you check the process binary options, you have it as black background checked. Most of the images that you're going to look at are going to have black background. They are fluorescent images, so you're going to have black background. And exactly what I was saying, so when you make an image binary, each pixel is going to be either 0 or 255 in a binary image. Guys, just because I am talking, I still expect your cameras to be on, okay? I want to see your faces, basically. Okay, so the reason why we're making an image binary is to segment our images. Yes, guys, please turn your cameras back on. I'm going very, very fast, and I want to make sure that you guys are focusing here, okay? So what we're trying to do is analyze particles via segmentation. So the key here to segment an image, and you guys are going to hear segmentation to ad nauseum because that's what you're trying to do to an image. You're trying to segment your image. You're trying to segment it into signal versus no signal. And the way you do this is by making an image binary. So you're going to say, here is our 8-bit image. This was on a grayscale, 0 to 255, right? So you see that this is our nuclei here, right? And when we made the image binary, all of this background now is considered, this is actually not correct, it's inverted, right? But I don't know why they did it this way. You're making all the background 0 actually, and all of your signal 1. So that's going to be 1. So now all of this that had many, many, many different shades of gray and different bit grayscale values, now it's going to have just one value, right? It's going to be just 255 or 0. That's it. There's no other option there. And this is a key to our segment, our image, okay? Okay, sorry. Okay. Yes, so this is a very, very, very crucial part. So we are going to have today, we're going to use the binary module, and we're also going to use the analyze particles module, okay? So what can you do once you have an image binary? So let's say this is our original image where you see all the different shades of colors of gray. Making it binary will make it either black and white, and then you can do a bunch of operations to this signal now. So you can erode, meaning you eliminate pixels at the edges. You can dilate, meaning you add pixels at the edges. You can open it up, meaning the holes within, you're going to just eliminate pixels. You can close gaps, right? So you see the E here is nice and close. You can outline, and you can also use it as just as a skeleton where you erode until a single pixel line is present. So there's a lot of different things that you can do once you have an image binary. The analyze particle, to use this, we have to make an image binary. So you're going to have to use the threshold. So we'll make an image binary. And from there are different things that you can select. So this is your original image, which we're going to play with. You can say, I no longer want to have the edges, right? So it eliminated everything that touches the edges. Sometimes this is useful because you cut cells off. So you only want to have full cells present. So you can just eliminate whatever is touching the edges. You can close the holes. You can do a size selection according to circularity, right? So here we're selecting a size that is very, very small. So here you're going to put the circularity to be a certain circularity, to be very circular, and the size to be a certain size. And you see now you only selected the small particles out. Then you can say, oh, I don't want it to be circular. It can be non-circular, right? So like a linear or a rod-shaped structure. And once again, you can select them out by size and circularity. So this is something that is, again, very useful when you're trying to analyze your images and you're trying to select out certain particles. Once you analyze the particles, you can generate it as a mask, right? So you can use different outlines of how to use this information. Most of the time, you'll have the original, which is just the thresholded, and then you generate a mask. And this mask then can be used to do all kinds of calculation. The software will remember the signal intensities below the mask. So you can generate certain things like average intensities or standard deviations of these intensities. These can be very, very useful when you're trying to analyze particles. Okay, so then one thing that is very important for image analysis is something called watershed algorithm. And the way this watershed algorithm works, and again, we're going to use this a lot, and I'm going to mention it to you a couple of times where it's important. This is, let's say you have multiple cells that come together, right? You kind of can tell that they should be two cells, but because the signal is so close together, the software doesn't recognize you. You cannot separate it out just by thresholding because the signal is very, very similar and they are together, right? So something that you can use then is the watershed algorithm. And the way the watershed algorithm works is imagine that these are your fluorescent peaks, right? So this is my signal, this is my signal, this is my signal. And this would be where normally I would be able to separate them out, right? But they look very, when you look at it, it looks like just one signal now, right? So what you do is, this is funny. I got these slides from somewhere. I think it's kind of cute the way they explain it. So imagine you start filling the intensities with water, right? That's why it's called watershed algorithm. And then you flood the two areas. So you have A and B areas, and those are two separate peaks. But you cannot determine, but this is what you want, but you actually, the way your signal looks, is it actually looks like it's merged, right? So you can't tell that there is a separate signal here and there are valleys here because you just have one big mix of signals. So you have one flooded area. This is what it looks like. But the software remembers that when it started filling these dams, there were two areas that were separated. So it puts a dam there. And then it decides, okay, this is going to be one signal and this is going to be the other signal. So this is how watershed works. It's something that you're not personally doing, of course. You just hit the button and it does it for you. But this is the idea. It starts measuring where the signal might be increased just a little bit, which is really difficult to see it with your eye, but the software can determine it and it will put a dam there. So this is our original image. So now if we use just the traditional binary thresholding, you'll see that there is this cell here is actually represented as one cell when we use the binary, but when we apply the watershed algorithm, it actually can tell that it's not one cell, but instead it's two. This guy as well, right? So it actually put a split there, and now it can detect it as two different cells, right? So here is one cell, here's the other cell. So it actually can see that it's two cells. So watershed is something we use a lot because most of the times you're going to have particles that are very, very close to each other, and you want to make sure that you're not miscalculating, right? You don't say that things are bigger when they're really not. It's just two together, okay? So this is all I wanted to talk about today. So I'm just going to walk you guys through these options in image J. I wanted to also check to make sure that I cover everything that's on your assignment. So this is going to be assignment 4, right? Okay, so let's look at this. So let me just, you guys gonna do the blobs. So this is going to be something that you're going to be worked with. I'm going to use the cell colony. It's just easy for us to do. You know what? No, why don't we just use one of my images? Okay, so we have the image. So the binary part is here. Remember yesterday I said to you guys, we're going to go over binary tomorrow. So this is why I didn't really discuss it yesterday. So this is where we are. We can hit make by. Okay, so you know what I'm going to do is I am going to make a bunch of duplicates here. Just so we can play with it. Yes. Okay. Okay.
Get the kids from there.
Oh. Have you heard from them?
Yeah, they're arriving now.
Cool.
See when you're done.
Okay. Larry, what's up?
Just want to tell you about Microsoft.
Microscope rules.
He's going to get the work done again tomorrow.
In the room? Okay. Okay. Okay, so I made just a bunch of them just so I don't have to keep reopening. Okay, so we can go into binary, make binary, and see it automatically said that this is 255 and this is 0. What did I say? This is not the correct one, right? So we're going to go ahead and binary options. We're going to make the background black. Oh, but I have it clicked. So what's the problem? I do have it clicked. So why is it not giving me? Why is it giving me this as 0 and this as 255? Let's see. This is where the options are. So let me just see my brightness. Here is the threshold. So I wanted to get here. So to threshold the image, for binary, you're going to go into image, adjust, and threshold, and this threshold menu will pop up. And this is what the other one looked like. So I have a dark background. I am not sure why it selected for my binary. Do you guys have the same issue? Why is it switching my color? I don't understand.
Can you just do invert LUTs?
Yeah, I did the invert and then it's correct, but it should be, it shouldn't do this to me. I'm not sure why is it, because I have it correctly selected both dark background here and I have, but maybe I'm going to, let me see what happens if I do this. Then it's correct. No, it's still not correct. It's still not correct, right? It just made the background incorrect. Because it still says 0 for this, and I need my color to be here 255, right? So we're gonna do that for now. We're just going to invert. Let me just see if I use this and I make this binary, what happens? Inverting lookup table. Yes, so then it inverted it. So I don't understand. I'm not sure why when you do it automatically from here, why it's not giving us the inverted lookup table automatically. But no matter what, you're never going to use binary just like this. You will always want to come and open up your threshold. So again, you're going to go image, adjust, and threshold, because when you get to the threshold, then you can actually select where you want to threshold. And a threshold is up to you. The threshold is up to you what you consider signal and not signal. So there's different options here that you can select. So this is the over and under. So everything here blue is going to be now no signal. and everything that is green is going to be signal. Black and white is probably the most popular one that everybody uses. So I'm going to say this is all signal here, right? And here you can just maneuver your own threshold. This is the hardest thing in image analysis, to determine your threshold. This is something that I would sit hours and hours and stare at images and try to manipulate to make sure that my threshold is correct. There are some automatic thresholds, right? Algorithms that people use. So you can click through them. This is this one, then you can have this one, right? There are different kind of methods and calculations that people came up with over time to select what is they consider signal and not. One of the most popular one is called Atsu, and it's also here. This is the most popular automatic signal detection methods. This is something that you actually see in papers, people using it. And usually I would start with this to have like an initial idea of what it's supposed to look like. And then I go ahead and look more carefully because you can still adjust. I think this is way too much selection here. So I would delete some of it, right? The problem is, as you guys can see it, is that when I eliminate from here, because this is too much, I eliminate some real signal. Do you guys see that? Right? So this is signal here, but now it's way overwhelming there. So this is when it comes to you trying to do histogram stretching and histogram equalization. So if you look at this image, let me just make a duplicate again. Which technique do you think we should use to equalize our histogram? Should we use the equalized histogram or should we use the normalized? What's the difference between the two? Remember, with the normalized, even if just one pixel is saturated, you kind of lost, right? So this pixel here is clearly saturated. You guys see it? So if I open up my histogram, you see I have a bunch of saturated pixels here at 65,535. So the normalize is out. So the only one that I can do is equalize. So I'm going to hit equalize. It's going to look like this. And now my histogram is going to look like that, right? So you see how it stretched it out? Yeah, you guys see it? So now if I hit the Atsu on the threshold here, this is what it looks like instead of this. So this is here. Come on. This is what it looks like it here. And this is what it looks like it after the histogram equalization. So what I can do here now is try to maneuver it a little bit to get more of the information that I want. It's kind of hard, right? So this is where the watershed would come in, right? So you see all of this, it would consider one pixel, one area, one object. That's not what I want. I want them to be considered multiple little punctas, which they are. So it seems like even though I did the separation, this is probably still better, right? So this is when it comes to you playing with the software to see how can you get the best out of your data. The problem for here is that we have a lot of signal in the middle and not so much at the edge, right? So it's kind of hard to determine what's considered signal and what's not. But once you're happy, let's say I'm happy with this, then you can make this image binary. So we're going to make it binary, and now this image is a binary image. You see all the white one is 255, and all the black one is 0. Do you guys see that? That my numbers changed? Here, I have not made it binary. I just thresholded it. So if you look at the values up here, you see this one still says, well, I don't know, 33,000 something, right? While this one says 255. Okay? So only once you make it binary, that's when it changes it also to 8-bit, and it becomes 0 and 255s, right? So those are the options here, right? So again, you want to threshold it, and then you want to make it binary. And once you made it binary, you can play with the options of erosion and all that stuff. So these are the different stuff that you guys can play with it on your own. What I do want to point out is this watershed option that we talked about. So if you hit watershed, you see it separated it out. So it thinks that this is one particle, this is one particle, and now it converted it correctly. It's still my signal, just the color changed, right? So instead of this whole thing being one, now it separated it out. Does it look perfect? No, right? If you look in here, this is the area that, this is the area that it thinks it's one particle. It clearly is multiple particles, but it's not good enough. But it's still better than this. Let's see this. So if you hit binary, make binary. Where did it go? Oh, it just made this binary. Okay. So this is my binary image without the watershed. This is with the watershed. If we measure the particles here, so we can go into analyze particles. This is where we were. We can just say all of it. We want everything right now. Display results. Okay, press OK. So these are the values that we are getting here. So altogether, we are getting 1,118 particles. If we use this here, without the watershed, so again, this had 1,118. Without the watershed, we are going to have this is our new value, which is 852, right? So it managed to get about 400 extra particles with the watershed. Is it perfect? No. So this is the reason why it takes a long time, and Fiji is not really developed for this. So IMARIS is going to do a better job at separating these particles out. That's the reason why we're paying the big bucks, right? Because you can't separate them out with Fiji. Even though this is a very powerful software, there are still certain things it cannot do. Okay, so again, you can just, oh, I just did measure again. So the total volume here is this. So it gives you an area. Sorry, let me move this. Okay, sorry, let me just clear this out. Don't save. And let me go here. And let's do this thresholding. Why do I have to go back and forth? And I'm just going to say apply. So even here, if you hit apply here, it gives you the same binary information. So you don't have to go to process and binary if you don't want to. If you hit apply here, it changed the information for us. So now we'll have all these particles. If you go into Analyze Measure, it gives us a total area with the mean, right? So it gives you that information. If we want to change what the measure is, you're going to go ahead in options. Is my measuring tool. Sometimes I'm blind. No. 1 second. Set measurements. Okay, hold on 1 second. Analyze. Set measurements. Sorry, it's right here. Okay, so if you want to decide what you get in your measurements, you go into Analyze, Set Measurements, which is here, and then you can determine other points that you are interested in. Standard deviation, shape description, whatever it is, you can just click here. Let's say we are interested in shape descriptions and standard deviation. I'm going to press OK. And now it gives us that information. Okay, so you can have all these other information generated from there. Okay, so did I wanted to talk about anything else today? No, I think you guys have everything that I wanted to talk about today. So again, the key for us here is for you to understand that you have to make an image binary. And the reason why you do that is for you to do segmentation. You want to be able to segment your images to where you can say, above this, I'm considering it an object or a segment or a signal. Below this, I'm considering it garbage. I'm no longer interested in that. Yeah. So segmentation is that's what you're doing. And once you segmented an image, then you have your information that you can use as objects. That you can do all your calculations that you are interested in. You can measure colocalizations, you can do overlays, you can do different things with it, right? And another key here is that the watershed algorithm allows you to, so as the software remembers, or not remembers, but as the software detects slight changes in pixel intensities that's hard for you to distinguish or hard for the software to distinguish originally. When you apply the watershed algorithm, it notices that subtle changes and it creates a dam there. So instead of one object, now you have 2 objects or 3 objects or 4 objects. And this allows you to do all kinds of measurements. Okay, so you can do the measuring as we did before, and from there you can analyze the particles, determining their size, their sphericity, and select out certain things. So the ones that I showed here, this option, all of these you guys can actually do on your own. These blobs are here, so you can just recreate all of this on your own to play with it. So the blobs are right here. Open sample blobs. This is the image that pops up, and you guys should try to recreate all of this just to see what you get, right? How to separate out these different structures on your own. Okay, and then play with these overlays and outlines and see how you can create masks. Okay, that's extra on your, I didn't This one is, in the first one, you're going to determine this thresholding menu. It's going to be a lot simpler than mine. You're going to use filter options. So in the second exercise, I want you guys to use the filters. So remember, the filters are these guys, right? These are filters. And then use different filters on an image and determine which one allows you to separate out the particles best. So you're going to use a filter, and then you're going to threshold, and you're going to measure the particles, and then you're going to tell me which one you think is the best to separate out the particles, okay? Yeah? For exercise 3, you're going to use a thresholded image from exercise 2 and pick 5 ways to change the binary image. So you can pick this image. You're going to do 5 ways to change the image. So arrow, dilate, open, whatever, and see what happens to the objects, okay? For exercise first, you're going to open the image that's on Brightspace, image number 6, and that's the raw image. And from the raw image, you're going to recreate this image. Is this clear for everybody, right? You're going to open image 6 from Brightspace, and you're going to recreate this image, okay? Is this clear? Sharifa, is this clear what I'm asking you to do? Yeah, okay. And then for the last one, not the same image that you already used, pick any of the other images that I have and do 25 steps. I just want you to randomly click on things, try to make sense of what's going on, right? And just try to, just play with it. That's what I want you to do. I want you to play with as many buttons as possibly you can, okay? Yeah? Okay. So are we clear? So I want you guys to play with the processing menu today, all these processing. You can use the analyze menu, measure and analyze particles, these. And then in here in the adjust, you're going to play with the threshold menu, okay? This is the threshold menu in here, right? So that's how you make sure that you are getting your images correctly, select what you consider signal and what you consider not signal. Okay? Yeah? Okay, so I see you guys tomorrow at 1. Any questions? Everybody's okay with Brightspace now, right? We all have the images, we all have the folders. I'll make sure that you guys can upload more than once. Okay? Any other questions? No? So we all good. Okay, so I see you guys tomorrow.